We're going to finish up chapter 8 today. Got a little practice first, and then we're just going to talk about a couple of the other things when it comes to equations. The biggest part of this is balancing equations and knowing what type of reaction they are. And actually, after these notes, you guys, I made up a PowerPoint where I have a reaction. You have to balance it and then tell me what type. They're all in the PowerPoint, but you can practice on it. And again, that'll be after these notes. They're there for you to help. Okay, here we got a reaction between hydroiodic acid and sodium hydroxide. Hydroiodic acid is HI and sodium hydroxide is NaOH. So two compounds, so the hydrogen is going to go with the OH and then sodium is going to go with the I. Okay, and again, this is easy to balance because they're all ones. So there's my equation. Pretty simple. Okay, what do we got here? Barium chloride. Barium is 2, chlorine is 1, so it'd be BaCl2. Again, you guys, do not forget that you have to write the proper formula. Magnesium is Mg and it's +2. Sulfate is SO4 and it's -2, so it's just MgSO4. Okay, so there's my two right formulas. So when I react these together, I'm going to end up with barium sulfate and magnesium chloride. Okay, they're going to switch. Okay, both compounds are ionic. Okay, so it's a double displacement. And again, barium chloride's going to go, the barium's going to go with the sulfate, the magnesium's going to go with the chloride. The really nice thing about them, and again, once I write the right formulas, this equation's already balanced. Okay, but remember, the positive one, the cation, is going to be listed first. They're just going to switch. So sulfate's going to come over here and chlorine's going to go over here. And that's a double displacement. Okay, here we have potassium phosphate and barium chloride. All right. Okay, so I'm going to end up with potassium chloride. Now it's not going to be K3Cl2, it's just going to be KCl because potassium's 1 and chlorine's -1. Okay, and then barium and phosphate. Barium is 2 and phosphate is 3, so it's going to be Ba3PO4 in parentheses 2. So I have to write the proper formula. Okay, Ba3PO4 2. So again, just because it's this on this side doesn't mean on the other side. Again, it wouldn't be K3Cl2, it's just KCl. So I'm supposed to figure out which one this is. All right. I'm going with this one. Oh, I was right. Okay. Don't worry about the no reaction. I'm not going to have you guys do that. But here, see how it's got, it's not, this one's not balanced. And this one, what happened on this one? Well, this one's not balanced either. Okay, so again, they're not much different. Heck, I don't know what the difference between, oh, all they did was change the solid. Oh, you guys, I wouldn't expect you to do this either, so don't worry about that part. That's a tricky question. But again, this one, to balance it, I'm going to have KCl over here and Ba3PO4. I know you can't see that in parentheses 2. When you have a crazy big one like that, Ba3PO4 in parentheses 2, this one, I'm going to balance this one out first. So I'm going to put a 3 here in front of barium, and I'm going to put a 2 in front of this one to balance out the PO4. Then all I got to do is look at, I have 2 times 3 is 6, 3 times 2 is 6, so I'm going to put a 6 here. Okay, so whenever you're trying to balance the equation and you got one compound that's, you know, kind of big, start with that one. It'll be easier for you to balance. Okay, ammonium chloride and sodium nitrate, those are all ones, so it'll be pretty easy. Okay, again, okay, so now when you're looking at chemical reactions, there is a transfer in energy. Anytime you have a chemical reaction, there's going to be a transfer in energy. Okay, they talk about that. We talked about this a little bit with specific heat, you know, but there's going to be a change in energy, and it's either in kilojoules or kilocalories, or joules or calories. Okay, if it's an exothermic reaction, and this is what most reactions we see are exothermic. Okay, if I take hydrogen and chlorine and put them together, I get hydrochloric acid, and it gets hot. The temperature goes up. So this is going to be an exothermic reaction because it releases energy. So heat is actually one of the products. Okay, so this is an exothermic. Exo meaning it releases heat. Okay, there are some that are endothermic. Okay, an example in our body is when we sweat. What happens when water evaporates? It takes heat with it. Okay, if without that, we'd be in big trouble. Okay, but here's an example. If we take nitrogen and oxygen and put them together, we need heat. Okay, so it's going to absorb energy. This reaction is actually going to get colder. So if you see energy on the reactant side, you know it's endothermic. If you see it on the product side, you know it's exothermic. Okay, if we were doing these reactions, this one would get hotter because it's releasing energy. This one would get colder because it needs to absorb energy for the reaction to occur. That's the difference between exo and endo. Okay? Okay, one of the things we talk about a lot with the environment is greenhouse gases. Greenhouse gases are methane, carbon dioxide. Carbon dioxide is a big one because whenever you burn things, combustion, you release carbon dioxide. Okay, carbon dioxide isn't a pollutant in the sense that, you know, it's not poisonous or anything. But now it's a pollutant because we have too much in the air, and what it does is it traps heat. Okay? What used to happen before we got too much CO2 in the air is that sunlight would hit, we'd use some of it, but some of it would reflect back into the atmosphere. Well, now because of carbon dioxide, we have like this blanket covering the earth, and it absorbs it. Instead of bouncing back where it's supposed to go, it actually absorbs it. So the earth is getting warmer. Okay, that's where you get the greenhouse gas effect. Like a greenhouse, you know, you have a cover over it so you keep heat in. Well, that's kind of what's happened to the earth. We have this blanket of CO2 that's keeping in heat that shouldn't be there. It should be heat that's escaping back into the atmosphere. Okay, so greenhouse gases absorb some of that heat and it warms up the atmosphere. Okay, so you're like, well, we live in North Dakota. Hey, it'd be nice if it was a little warmer, wouldn't it? Well, the other thing that CO2 does when you change this, you get variances. You get spots that get really hot and you get spots that get really cold. So it could make it colder. And think about poor California, the whole West Coast and their drought. You know, there's so many of these fires because they've lost a lot of their moisture, the heat has gone up, and they're losing a lot of their land because of fires. So all kinds of bad things happen, okay? The greenhouse operates just like this, where it warms, you know, but here you use glass and you use a cover, but this is, that's greenhouse on a small scale. What we're doing on a large scale is we're putting a cover on the earth and we're not allowing the heat that's supposed to escape back in the atmosphere. It's not happening, it's staying there. Okay, the biggest thing that causes that is burning fossil fuels. Okay, burning natural gas, burning gas, and burning coal. Okay, we're putting way more CO2 in the air than there used to be, and that's causing us problems. Okay, this shows you the CO2 concentrations. 1959, it was way down here, and now it's way up here. Now, some people say, well, it's cyclic. Well, yeah, it is, but cyclic means it goes up here, and then it comes back down here, and goes up here, and comes. It's not cyclic anymore. It's increasing at an alarming rate, and that's causing some serious issues. Okay, they used to think that global warming was kind of a fake science, a farce, but there isn't a scientist that tell you that global warming isn't occurring, okay? It's risen, you might not think, well, that's not so much. It makes a big difference. The oceans are getting warmer, and when the oceans get warmer, they get more acidic because they absorb, you know, they change their whole chemistry. We got all kinds of issues that are occurring. And the other thing about the oceans getting warmer is it used to be storms would go out over the ocean was cold, it absorbed the energy from it. So a hurricane eye would go over, and it would break up. When it came back to land, it would just be a tropical storm. Now it goes out and it actually gets more energy because it's warmer, and then when it comes back, it's a lot worse than it used to be. That's why we have so many hurricanes now. We've always had them, but they just weren't so devastating. But now they have a lot of energy and they cause a lot of problems, way more than we used to have. Okay. Another one is methane. Methane is natural gas. If you go by like power, you know, the pumps, you'll see sometimes a little flame being burnt. Methane is way more potent than CO2. So what they've decided to do, instead of just letting the natural gas be released in the air, they actually burn it because CO2 will be is less worse than CH4, methane. What they really should be doing is collecting it. In the East Coast in Pennsylvania, they frack just for natural gas. Okay, they want that CH4. We get it because we're fracking for oil, and we just let it escape into the atmosphere. So we need to collect it and do something with it. Okay, so here's the level of methane, and you can see that's going way up too. Okay, it's totally increased. Some of it is because of agriculture. Cows release methane, but we don't want to get rid of our cows because we like our hamburgers. So instead, we need to worry about the methane that we're letting escape in the atmosphere and do something about that instead. We got to do stuff that we can deal with, not the natural stuff, but the other stuff. Okay, so that's it for this chapter. We're done with chapter 8. Make sure you keep up with your reactions. And again, I'll have a PowerPoint that has an equation. You have to balance it and tell me what type it is. It's all on the slide, but you can do it one click at a time so you can practice doing them. All right. Remember, if you got any questions, watch the videos and shoot me an email. I'll do what I can. Plus, remember, we have Philip and we have Rayanne. Those guys can help you with this stuff. Okay. All right.